For in this meeting, so plus production tools in OpenBridge Designer. So now, before to start presenting what we do in OpenBridge Modeler, right, or OpenBridge Designer, let me show you how we do this when we have the traditional bridge workflow and how this has changed, right? As bridge designers or bridge detailers as well, we're used to do analytical modeling, right, and create a model in our structural design software. But then through a manual process, then we develop plan sheets, calculate quantities, and all of that, right? And then also through a manual process, then we publish the information for construction, inspection, and all of that, right? So we were creating a model, but the model that was purely structural. Now, what we do now in this BIM workflow now is to say that no, 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 we're going to create now a physical model. So the way the bridge is going to be constructed, that's what we're going to be developing in our computers. And from that model is we're going to extract 2D drawings, reports, and if you want 3D PDFs. And that same physical model, it will be transferred through an automatic process on one side to the structural design software, right? So we don't need to remodel anything again. And if some changes happen, well, through that automatic process, we just go and feedback that new information to the physical model. At the same time, if I need to, through another automatic process as well, I can quote unquote cut cross sections. So a cross section of the model, for example, on the deck will be your typical section, right? A cross section cut along the pier line, that's your elevation view of the pier, your top view of the pier, your side view of the pier. So that's how we produce the 2D drawings. Basically, quote unquote, cut sections, right? Assembled into a sheet, all connected to the model using the technology of reference files, right? And the detailing will be done in 3D as well. That's how we generate the design documentation, right? And then after that, all that information, either the 3D model or the plan sheets that you generate, or both, even better, it will be transferred to the construction, inspection, or maintenance operations of our structure. So then for that, what we use is OpenBridge Designer. In OpenBridge Designer, we created a dashboard that allows us to model the bridge in OpenBridge Modeler. And if this bridge is pre-stressed girder, then we calculate it, we design it with Bridge Concrete. If it's a steel I-girder bridge, of course, we will send it to Bridge Steel, right? So the idea of OpenBridge Modeler or Designer is the collaboration. That same model, as I showed you before, with this BIM interoperable bridge workflow, that model will be sent or will be used to design with Bridge Concrete or steel for detailing. So then we will use Pro Structures to do it, right? And that information will come from, for example, OpenRose Designer, as we need the alignment and profile to create our bridge, right? So that information will be shared. Doing that, of course, we are not copy any file. We don't do cut and paste. We just read the work, read the information, of course, eliminating errors. Everything works inside the MicroStation platform. Everything is DGN, so there is no translations either. And then we can maintain the information where it belongs. For example, the alignment and profile and super elevation belongs to, generally, the roadway engineer. My bridge, well, is my bridge, right? So it belongs to me. I'm doing this with OpenBridge Modeler. The designer, well, the designer will use the bridge and he owns that information, as well as the detailer. He's using my model, my bridge model, to detail. So he's the owner of the rebars, but I'm the owner of the structure. So all that sharing, it's available. Now, on this model, then focusing now on today's presentation, Well, how we generate reports and quantity? What you can generate now with this latest release of OpenBridge Designer? We can generate geometric reports and quantities, right? So we can generate deck elevations, beam seat elevations, pier elevation. Basically, we can report anything related to the bridge, either geometrically or quantity-wise. Now, think about it. We're reading the alignment, profile, and super of the bridge, meaning that we can just access the information, the real geometry information of the bridge, right? So, for example, deck elevations. We're using that real geometry. So I invoke on analysis and reporting deck elevations, select how many points do I need, and along what elements. Maybe along every beam path, right? Every tenth, as most DOT wanted, and that's your report. Reading the alignment, profile, and super elevation that was applied to the deck. And then as well, I can also export that to not only print it from here, but also export to Excel or create a PDF or even send it directly to a PDF file. So I can do all of that, right? So if any modifications happen, well, the next step is maybe I need to rerun deck elevations. If my profile gets updated, right? Or even the super elevation is given to me. So I can do all of that. Now, not only I can get deck elevations, but beam reports. So on the same token, I just select it, right? And it knows my bridge. It knows where the beams are, of course, and then it gives me all the information related to the geometry of the bridge. Imagine doing this by hand, right? Calculating every beam elevation, every hunch elevation, the hunch thicknesses of every beam. If we do this in 2D, I'm talking the old way, right? Everything was a geometric calculation. Here is basically we're reading that information from the model directly because the model is geometrically accurate. So it's just a matter of requesting the report, as simple as it is, right? So, and then on the same fashion, we can ask for reports on the pier. So I can have pier information on that too, right? This is just the beam part of it. Now, also, I can generate beam seat elevations, right? As you place the bearings, what are the information of that beam seat? And it's not just width and thickness because these beam seats, for example, could change, right? If it's in super or not. So we can also give you the elevations and locations or that four corners of that beam seat and see, well, if it's appropriate or not, or you can accept the geometrical calculation or not, depending on the geometry of that you are getting, for example, for a heavy super elevated section. So maybe not use beam seats, but maybe step the cap of the pier, right? So, and as is not a special setup needed on that, it's just a matter of, as I'm doing here, just selecting the report, right? The same with the piers. I can just ask for one pier unit, for example, and say, I need a report. So all the geometrics of that pier configuration, top cap, bottom cap, flanges, uh, cap corners, top and bottom elevation of the footings of each one of them, it's being reported to. So you can report on that. Also, you can check your input as well if you have entered the right dimensions. So you can get all of that with these reports, not on the piers, but also on the caps and the abutments too. So all that information you can get at every point. So rather than selecting on the screen, that you can do too as well, I mean, nice to have the report handy. Now, what about camber? Camber has to deal with design, right? So what I do here is I finish the model and then I send this model with that interoperability with LibBridge Concrete. Now, in LibBridge Concrete, I design that information with LibBridge. When I finish the design, right, everything is calculated, and I bring the information back to OpenBridge Modeler, right? When I bridge the information back, the software answers me with this dialog box in which I say, well, do you accept the changes that may have happened during the design, right? Changes that could be, for example, a beam size. I changed the beam size of my model because the structural requirements, require a different size. So I'm unwilling to accept that. I can say yes, I can say no. And as well to bring the camber deflection calculations. And that's what I'm doing here. So if everything is okay, I would say, well, accept all the changes, bring it up, right? And then I can ask for, on the reports part, right? I can ask for the camber report. So the camber report, I can add extra camber, but here what I do, that, read it from LibBridge Concrete. So bring that camber for that particular beam that I designed, or the whole bridge, into LibBridge Concrete, into OpenBridge Modeler, I'm sorry, and then bring the new calculations here, right? So I can do this as well. Bring design information and incorporate it into a full camber report, and even generate discrete elevations if you need to. No? Now, what about quantities? Quantities, we're constantly improving that. So in quantities, we give you concrete quantities. You can also add certain costs to the material definition, right? That you define in the material library. So as you place it, the bridge, and depending on the material types that you use and how discriminating you want it to be, then we can give you the quantities at the level of detail that you want it. Like, for example, different concrete types from the deck, for the piers, for the footings, for the cap, for the columns itself. So it's just a matter of you discriminating uh, the different materials that you want to use. So, and the report is quite simple. One more time, analysis and reporting, and you want quantities, and that's it. So as you place the bridge, the different elements, like the abutment, the columns, the beams, you can specify a material type, right? So the software knows where the materials are already, because again, you place it, right? And you can generate this quantity report. And using our report engine, well, you can email it, you can create a PDF, or you can send it even to Excel for that. Right now, all these definitions that you see on my screen, right? Steel 1, steel 2, bearings, concrete type 1, concrete type 2, and all of that. So it's all defined in the material library. So we provide you some materials, you can edit them, and what's on the works is not only to do this, but actually associated at one time each item to a particular pay item. A pay item library may be coming from a DOT. So we can associate these materials to that pay item and give you a report by pay item. That's on the works, okay? But so far, you can just do the materials as you define it in your material library. Now, something new that came on this release is the ability to generate quantities for excavation, okay, for footings and abutments, and you can control what slope you want to dig in that trench or that hole for the isolated footing, for example, right? Or you can also say, well, I'm doing a sheet pile, so it's going to be a vertical slope. So the way to do it, it's all in MicroStation file, right? And the side slope has to be rise run, or you can do it as a percentage, as it shows on the screen, like 1-to-1 slope or ratio is 100%, right? So the way it's done is actually pretty simple. You just select the footing here and say, I want to place an excavation. So place the excavation. Remember, on your bridge is already the DTM or the terrain already selected. You just need to say, well, this is the terrain now. And look at the dialog box asking you for the name of the terrain. What is the horizontal offset? So here's going to be from the footing 6 feet out, all right, with a slope of a 2-to-1. And it's going to be sweeping an angle around the corners of 5 degrees. So saying that is just a matter of selecting the terrain. It picks up that information, and then you will just need to control the offsets. So it's going to be 10 feet out away from the footing itself that I'm going to select, right? And since you know it's a pier unit, it's not going to create a hole for or a trench for each footing, but it's going to create it for both of them in one shot, and that will do it, right? So it creates sort of a supplemental DTM that controls the excavation quantity from the terrain at a 2-to-1 slope, 10 feet away from that footing, right? Uh, so then also after that, you can go to your properties and on Windows on Explorer, and it will check the excavation under each support. So that excavation is recorded under each support. So here you go footings, right? Um, on that support, and that's an excavation item there. You can ask for information there or properties, and I will give you the quantities. We do not have it yet in a report, right? But again, that's on the works too. So we need a report on that. But then so far, you can get an excavation quantity just digging into the peer properties and look for that excavation item that you see in my screen. Oh, oh, oh. Hello, hello. Uh, Model annotation, right? Now, model annotation is handled the same way as in being done in OpenBridge Designer. Again, we incorporate a lot of the features in OpenBridge Modeler, a lot of the roadway features, like creating alignments, profile, and as well as annotating. So for the ones that are not familiar with that kind of annotation now, actually it's very simple. Since they provide you the alignments already on the screen for the roadway guys, right? So you just need to activate it and make that lines a geometry feature or geometry baseline in this case. As you select that this is a geometry baseline, right? So the feature knows that, oh, a geometry baseline can take annotation, right? So then what you need to do is just go into OpenBridge Modeler, into analysis and reporting, and say element annotation, annotate the element. And the configuration that you have in your organization at a particular DOT, or the ones that come from default, it will just annotate it your alignment, right? Also, what you can play with it is the different drawing scales that you can activate as well. So you don't need to replot that we used to do before. To replot and replot for different scales, we just switch it and the text size will change automatically for that. So for example, here, as I'm showing you this, right? So we got this red line and say, look, this feature is going to be now, or this line that I'm going to select, it's a linear feature, or it's an alignment actually, it's an alignment feature, and this alignment is geometry. Because on that feature, right, it was defined that it's an alignment, it's a geometry alignment that it can take annotation. So now it knows that these lines are geometry and can go element annotation and just do it. So it knows by the setup that it needs to be annotated following stationing. Now look, the text is too small, right? So I can annotate the other one too. But again, the text is small. So maybe I'm not going to be able to see it on my plans because maybe I'm not using the proper scale or my sheets need to be produced at a different scale. So what I can do is change the scale automatically because that text reacts to it and done. So you can do these too. Okay. And then as you switch scales, all these scales need to be predefined, right? So the ones that come with the software, you can use it, of course, and it applies a different text size. So each scale is associated with a different text size, maybe even different spacing for the stationing, right? And it's just a matter to activate it when you define. Now, why plots annotation? Well, because it knows that this line that you just selected, it's an alignment and it takes annotation. Okay. Any other line that you may select, it will not do that. Also, on this release, as a new improvement on that, we have incorporated the new way to produce plan sheets or plan and profile sheets. Okay, so you will have a 3D model, of course, in OpenBridge Modeler, but then you can dynamically cut uh, 2D views. You know, we don't call it sections, we call it 2D views because this is all reference to the model, meaning that any changes in the model will be reflected in your plan sheet. Obviously, that will require definition, what boundary to use, I mean, what frame to use, and what scales you are going to be plotting your sheets. Once the setup is done, then through the use of dynamic views, right, and adjusting the scales, you can generate these typical sections uh, on your structure, right? Now, we have two ways to do this. One is just by pure dynamic views. So we can just go and cut a section, right? Dynamically, I would say. So say on this area, for example, I will just go one more time to analysis and reporting and say, I need a cut. So I need a dynamic section. I will select my alignment and just say, along this section, I just wanted to cut a slice there, right? Data point, apply a certain depth. You can regulate it, maybe it's a cut. And then here comes your definitions as all these drawing sheets, they are DGN files, and where your sheet border will be generated to, it needs to be set up. You need to configure this in OpenBridge Modeler. OpenRose Designer, for example, it has its own configuration too. So to accommodate what size of border you want to use, what type of border you want to use, and all of that, depending to the scales you use. So you need to configure that. But when it's done for the standard operator, it will be just a matter of selecting the scale, the size, and we say, well, let's proceed. Let's cut a section. I mean, I'm not cutting a particular sheet. I'm just cutting a section along that, and it cuts everything it sees, right? So not only that, you see the line at the bottom, it was a terrain because it was I would say a deep cut, right? But it sees everything. Everything is cut. Everything that is cut is reflected on that 2D view. It's not drafting, it's a 2D view being referenced on that. Now, on the other hand, these dynamic cuts could be anything because look, before it was zero, right? So it was transversal to the alignment. So I'm cutting here different. I'm cutting here along the alignment, right? So what do you think I'm going to get? I'm going to get the plan elevation view. What about that? Right? So, but these are like cuts where I want it. They are random cuts, and I can just check my design like that. And you see, that's the pier, that's the other footings, and that's another terrain below that. So I can cut a section basically anywhere I want it. It could be transversal to the alignment like I did, or longitudinal like I did here, and then I may have a plan elevation on my bridge at any point, right? So this is just the dynamic views. Now, in a more formal setting, I can actually generate a drawing. I can configure it the way I want to see it in a set of plans, right? So for that, I will need also configuration. But we have predefined cuts, like dynamic views, you've seen how it's being performed, right? Place a line, cut, right? But here, what we have done is apply basically the same technology that you saw before. But now we say, I need a cut right on the pier line. So yes, I can place a dynamic view along the pier line, snapping to the lines, but I would rather do it with the software because the software will know the extent, the depth, and everything else. So it's just a matter of selecting that I need a section, a typical section. It will be a transversal cut, right? Like that. Uh, along the peer support, for example. So I don't need to set up anything. I just want that, a typical section like that. Or I can say on my drawings, I want to create a peer drawing. I can also set it up, what dimensions styles to use. So this is not just a cut, it actually will dimension that. So here I'm selecting a peer drawing, and I know what to select. So it knows that's a peer, it knows their dimensions and the depth and all of that, and it will extract these automatically. But look, as I did the settings, and you see that I was applying some dimension styles on that, and selecting the proper scale, when I will select OK, it will cut the three views of my peer. If I were to do with dynamic views, I have to do three cuts at the same time. Here, it will just do it all in one shot. And all of these are reference files. So you don't like a dimensioning style, or you want it to look a little bit different in a different position. It's just a matter of you defining the sheet first, right? You have to set it up, and also play with the dimension styles to see which ones you don't want to do, how you want to cut. For example, here the piers are too deep, so they are not fit on the file itself, so I can put cut lines there automatically. So this will be the full proper setup of a sheet. And it's all reference again, right? So you can do all of that. Now, what is the next step on that? So you can also do the sheets, right? And adjust it and move it. And if you change anything on the abutment itself, for example, I would change the dimension here, right? Your sheet is not static. Your sheet will change. As you select it, these are reference files. You see how it changed? These are reference files or a different view of that 3D model in anything you can change, right? So that's the advantage again of being model centric, that all of these cuts are not static ones, are dynamic cuts. Well, that's their name, dynamic views. So we can just do all of these fairly automatically, right? So, and then my typical section is also defined. I just have to properly position that onto the sheet. Also, what we include now in this latest release of OpenBridge Designer is that now we can really produce sheets, individual sheets, like plan profile sheets along the alignment. And we use the same engine, exactly the same engine as um, OpenRose Designer, right? So, well, let's see how this is done. Actually, it's very simple too. It's the same tool, right? So we're going to generate plan and profile sheets here. So, and then I have my plan, my profile view, right? But then look what I'm doing here. I'm placing a 3D cut along the profile. So it will reflect, right, my bridge in 3D. So that's the trick, to put the bridge in profile or to put any 3D stuff into the profile. So I just select a 3D cut into the profile menu, and then I see my bridge. Now the next step is to create sheets, right? So it's create sheets by boundary definition. All of these, you see, for example, drawing sheet, NCT plan profile, this is all set up already. It's kind of a drawing sheet or your template of cutting. So here I will select in three sheets, right? In plan. Now I switch that and say using that plans as a reference, cut the profile. And then proceed after placing that, proceed with the cutting of the plan and profile sections. So select the scale, select the annotation scale for that. Right? So, and then just say, okay, so it will create the individual drawings and it will create the sheet if I want to. So as I hit OK, all that information is processed and I have plan and profile sheets. Right? And one more time, these are also reference information. So this is not copy paste, it's just reference information of your design. Now, the next step on annotation, right? It will be rebar detailing. Now, this rebar detailing is done in pro structures, pro steel, pro concrete, with the advantage that, as I said before, you are the owner of your um, of your model, right? But the detailer is the owner of the rebars. So he will open pro structures, right, and detail my model with this software, but referencing my model. He's not going to copy the model. He's going to reference that. And in that reference, he will annotate the rebar, right? So you just need to create, as I said here, a new 3D DGN file, right? If you want to create different jobs, like for example, you have maybe people working on different piers. You got 10 piers, so you may have 10 different 3D DGN files, right? For pier 1, 2, 3 to 9. And then reference that, reference my model, that particular pier. So they are all referencing the same model, but they will just annotate pier by pier, for example. Also in Pro Structures, you need to define the standards, right? So standards on how to label and what rebars to use in the US, imperial, metric, or depending on the state or the country that you're in, all these rebar detailing standards change. So this is something that you have to set up. We have stuff out of the box, of course, but you know that, for example, here every DOT is different in how even they call the bars. Like Texas have the Z bars, in Florida we have the T bars, and in all different locations, and or depending where they're located. Like Virginia has the PF bars because they are the pier footing bars, for example. So you have to configure that. Why? Because when you do quantities and annotations, Pro Structures will annotate according to your standards. Anyway, fairly um, the process is fairly, I would say, easy if it's a regular structure, right? Because pro structures have information ready for standard elements like footings, columns, right? But if anything is special or variable, there is a little extra work involved in creating what we call a guideline to detail that. So this is something that also you can take advantage of and create templates and start annotating all these columns here, right? So these are, for example, predefined elements. So it's a square column, a cylindrical column. So all of that is fairly easy to annotate in full 3D, right? So here is just a matter of selecting the structure and what is the bar arrangement that you want. And this is detail, shop drawing detail level, right? So there is nothing schematic on that. This is really using the rebar, the lap lengths that it needs, the dowel lengths, the hooks that it needs, the pin radius that you need to bend each hook, and all of that. So this is something that you can also take advantage of if you get the model right. So this is doing this in Pro Structures, but again, your uh, your model is being referenced into the software to be used as a base of your detailing. And then from that is when, again, using drawing composition tools, now these in Pro Structures, right, you can generate sheets the same way that we did it before, but now you have to do it into the Pro Structure level part, right? And get quantities from that too, because remember, you're doing a 3D model, right? So you can just annotate the different bark marks that you want your own, one more time, your own definition, your own definition, and achieve this, right? So the different bark marks or different barks IDs that you want for your bars could be generated and do it as part of your setup. So this is also part of the setup, uh, and it will just differentiate between among the different IDs and as well as the different quantities that it needs to report. All that information will be sent to an Access database for further manipulation if you needed to, but then also it can create the different bar bending scales that you want to generate, right? And the bar bending schedule could be a schematic view or just a list of quantities. So a lot of options here that Pro Structures, Pro Concrete can give you on that one, right? And it can recognize any type of bar or any type of bending. So that will be the ending process of your whole modeling that started again with a line, then you develop the bridge, then the quantities, right? The geometric reports, the creation of plan sheets, and now with full detailing of your bridge. So, because at the end of the day, this is what you want to generate. A list of quantities, as I said, a bar bending scale, all part of the 3D model. So you can just generate this in great detail. Uh, and then from that, not deviating a little bit from plans production, then you can do all kind of clash detections, constructability, and all of that. So all of that could be fairly detailed uh, with high precision, just when you have a 3D model. And as I said, with great detail, right? And there is no shape basically that Pro Structure cannot do. So then you have it. And these are all the uh, plans production tools that we have so far in OpenBridge Designer.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.